Here is question number 41, everyone. The radioactive nucleus can decay by two different simultaneous processes. If the half-life of process are 20 days and 40 days, then effective half-life of nucleus will be what? Now, in such kind of questions where the two decays are going on simultaneously, the effective half-life period we can write by the formula T1 T2 upon T1 plus T2, where T1 and T2 are their individual half-lives. Putting the values 20 into 40 divided by 20 plus 40. Solving 20 into 40 divided by 60. After solving, we will get the effective half-life period for the process will be 40 by 3 days. Option number 3 we can go with. Now move on to the next, that is 42 number. Here is question number 42, everyone. When 90x288 gets converted to y80 260, then the number of alpha and beta particle emitted will be what? Now let's write the reaction first. X nucleus 90 to 88 getting converted into Y nucleus 80 to 60. Suppose m number of alpha particles are emitting and n number of beta particles are emitting. Alpha 2 4, beta minus 1 0. So now we can write atomic number must remain same, so we can write 80 plus 2m minus n must be equal to 90, or 2m minus n equals 10. Equation number 1. We have to calculate m and n actually. Mass number must also remain same. Therefore 260 plus 4m must be equal to 288, or 4m equals to 28. M we have got 7. So number of alpha particle we have got 7. Now let's go for the beta. From 1 we have 2m minus 10 equals n. So m has 7, 7 to the 14 minus 10, that is 4. So number of beta particle is 4. So alpha 7, beta 4. Option number 1 is absolutely correct. Now move on to the next, that is 43 number. Now here is question number 43, everyone. As shown in circuit, the respective values of I, ID and I1 are: forward voltage drop across silicon and germanium are 0.7 volt and 0.3 volt respectively. Now let us modify the circuit. 10 volt germanium diode can be replaced by equivalent drop, that is of 0.3. Silicon replaced by equivalent drop, that is 0.7 volt. 1 kilo ohm resistance here, that is 1000 ohm we can write. 0.5 kilo ohm resistance right here. Current are given. This is I, this is ID, and this is represented by I1, and we have to calculate this I, ID and I1. Consider it as loop 1 and this as loop 2. In loop 1, applying KVL, we will get 10 minus 0.3 minus 0.7 minus I into R, that is I into 1000 will be 0. From here we will get the value of I, that is 10 minus 1, 9 by 1000, or we can write 9 milliampere. Now let us calculate the current I1 as well. I1 can be written as the total potential drop 0.7 divided by total resistance 0.5, and here it is in kilo ohm. So when we solve, the answer came in milliampere, 1.4 milliampere. Applying the Kirchhoff's current law for this junction, we will get the current ID as well, which is given by I minus I1, or 9 minus 1.4 given by 7.6 milliampere, and therefore we can write in the order I, that is 9 milliampere, ID, that is 7.6 milliampere, and I1, that is 1.4 milliampere. So this is the order. Now let us find out the options. Option number 1, perfectly matching, so it is absolutely correct. Here is question number 44, everyone. Which of the following gates represent a NOT gate? Means we know very well for NOT gate, if input is A, output must be A naught, and input is A naught, output must be A only. So let's see. A, inputs, single input is given which is bifurcated into two. So A, another A, so A and A always gets you A. Option number 1 goes wrong. Option number 2, let us check. A, you are providing here A, two inputs going through NAND gate. So A dot A whole complement gets you A complement. Now you have given the input A, but after that you are getting A complement. So 2 is correct. Third, again you are giving A, but with this NOR, complement is added due to this bubble. So A plus A whole complement gets you A complement. Again A is getting converted into A complement, so option number 3 is also correct. We can say that option number 4 is true, both 2 and 3. Now move on to the next, that is 45 number. So here is question number 45, everyone. The common emitter amplifier has current gain beta 50, input impedance 2 kilo ohm and output impedance 1 kilo ohm. The voltage gain of amplifier will be what? Voltage gain AV can be written as beta times R output upon R input. Beta is given 50, output is 1 kilo ohm, input is 2 kilo ohm. After solving, we will get the voltage gain, that is 25. AV is 25, and therefore we can say that option number 4 is absolutely correct. So we will go with option number 4. So now we are done with physics portion. Bye bye everyone, all the very best. Thank you.